Engine ignition, 2, 1, 0.
0.
Release.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
Look up, past the clouds, past the satellites, 54 million kilometers away. Something is moving. Alone on the Martian surface, crawling over rock and dusts, is our rover. Its mission? To find evidence of life. Signs of life. Traces of life, written in dust, in gas, or in rocks. Here on Earth, our job is to build its brain, one node module at a time. And today, we're going to build a library that helps it capture the atmospheric metrics. Store it in the database, or somewhere, and analyze it. The catch that it has to work every time on Mars, and with only what Node gives us. Hold on. So hi, fellow engineers. I'm Sagi Levanon. During the day, I'm the VP R&D of Watch, a digital healthcare company that helps patients and physicians build their care plan and track it. But at night, when the moon is shining and the stars twinkle, I'm taking on the role of NodeTLV's head engineer of space department. So we want to build a rover and deploy it to Mars. But it's not just a rover, it's a complete lab. And it's a one that wakes up every Martian soul and go to work. And our task here is to support this mission, as I said. All right, so let's do that. We're collecting some data. Temperature, pressure, wind, light, gases, everything that can tell us what's moving through the Martian air. We don't need real-time feeds. We're going to use fixed intervals that fetch all the data and store them somewhere. That's good enough for us. Our engineers and data scientists asked us two major requirements. One is that this data set cannot be saved if it's partial. Either save everything or nothing. Basically, transaction. The second requirement is that the data should be accessible for later analysis. They want to slice and dice it, they want to query it, and we need to allow them or to the rover itself to do it. So basically, we're building a DAL, data access layer, a simple one. We're going to have a function here that's going to get all this data set of data and persist them into some kind of a database or repository. And on the other hand, we're going to have a function that allows us to query the data and fetch it from that repository. But what is that repository? So we have a few challenges that we are facing. First of all, we're on Mars. We have an isolated environment. We don't have high, broadband internet. We don't have AWS, Azure, or GCP. We need to use our own resources, and they are limited. Second, we need to support ACID, okay? Atomicity, consistency, you know the acronym. Basically, we need to support transactions. Third, we need to be able to query this repository and be able to fetch data, ideally with a language or some kind of standard that everybody knows, SQL, for example. We would like to have to minimize the number of dependencies. I mean, using NPM packages is a bless, right? We all use it. It's standard to do everything, right? But maintaining it is hard. And we are prone to dependency conflicts in a big code base. We're allowing attack surface. It's a new attack surface for security issues. So we want to minimize the dependencies as much as possible, not to mention that we are running in a very isolated environment. It needs to be quick. We can't wait for hours or even minutes or seconds. It needs to be something that fetches the data and saves the data fast. We have intervals that are running. We have other code that is dependent on this. And lastly, it needs to be reliable. We need to find a solution that has been around, it is battle-tested, and it just works. So what are our options? I think always the go-to is relational database. Postgres, MS SQL, whatever, right? But that's a problem, because we either need a network to go to a server, or we need to install the server locally, and that exhausts our resources. We don't have a lot of resources. So the plain relational database is out. We can use a time series database, influx, timescale, whatever. Some of them are just extensions of the relational database, so that's no good. Others don't support SQL or don't support transaction. So that's out of the window as well. Lastly, we can try something more embedded, something like DuckDB. Are you familiar with DuckDB? So DuckDB is like ClickHouse, but small and embedded, okay? But like ClickHouse, it's more for OLAP, online analytics processing, and less for transactions. So these options are out. Let's think about SQLite or SQLite. So SQLite is a lightweight, serverless, self-contained database. What does that mean? Self-contained means that the entire database is a single file. No multiple files, no whatever. It's just one file. You can even email the entire database if you want to. Serverless means that it doesn't have a server. It runs in process, okay, or in Node. There is no server that you need to deploy. Zero configuration means there are no configurations. There are no config files. You don't need to configure users or anything like that. Zero configuration. You just create it and start working with it. ACID compliant means that this is not a toy. It actually supports transactions. SQL support, it means that you can run SQL on top of it, and it supports most of the flavors. And it's free. You can take it anywhere you want and just use it. No fees, no licenses, no nothing. This is why SQLite is actually the most deployed database in the world. Okay? Every internet-connected human being on this planet is using SQLite, whether you know it or you're not, or you don't. It's in your phones, it's in your browsers, it's in satellites, it's everywhere. Okay? And it's safe. And now it's going to make its way all the way to Mars. All right. So there are a few options how we can interact with SQLite. First, there's SQLite 3. That's the oldest one, or more than a decade-old package. It's been around, battle-tested. It is asynchronous using callback functions. They have roughly 1 million downloads a week. That's SQLite 3. Can anyone guess what's the next one? The amazing name of better SQLite 3. Better SQLite 3 came a few years later. They're taking a different approach. They're going to the synchronous mode, and it is much more performant, and it's focusing more on ergonomics. It also brings some tooling and some other corner cases that SQLite 3 doesn't handle that well. And now we have Node SQLite 3, okay? Node SQLite, which means that you don't need any library. It's native in Node, okay? All three work, but only one part is part of Node 1, and that's a big difference. There is less dependencies. It just comes out of the box. So what do we have? We have a solution that is native. It's synchronous, exactly like better SQL 3, and it allows you to have a simplified deployment. And what if it doesn't work? No worries, you can always roll back to better SQL. It's more or less the same thing. But I wouldn't do that because I haven't seen any issues with the native solution so far. All right. So let's start building our solution. We want to save some data, right? We have options to either use it as in-memory or save the data to a file. In-memory is more used for temporary data or some session-related data. If we want to have a long-term, we want to save it in a file. So we're going to save it in a file because we have a requirement to do some historic data. This is the data that we're going to collect, these fields, and we're going to just make them a DB table. Okay? As you can see, SQLite 3 is like any other SQL database. It has all the things that you're used to. All right, so now that we've defined the schema, we can start coding. What I want to show you first is the things that you don't see here. What you don't see here is dependencies. There is no dependency for any library. Only dev dependencies, just for types and stuff like that. That's our package, JSON, and it ships with no dependencies. That's amazing. All right, so we want to start coding. We're going to have some basic library code, just exporting some stuff, defining some types, and then let's dive into the major part or the big deal, which is the database itself. So first, we want to do import database sync from Node SQLite. That's the first line that we see here. That's all we need. Next, we want to start building the database. So we're going to do new database sync and then write the name of the database. That's all. That's all we need to create a database on the disk. As I said, no servers, no defining users, no configuration files, no nothing. All right? That's it. All right, so let's build our tables now. We're going to run a function called exec and just write our simple create table to create these tables. You can note two things here. You can use ORMs, KNX, all these kind of things. I'm not. I'm writing pure SQL here. And the second thing you can note is that the strict at the end, that's a SQLite thing. If you don't write it, it's less type strict, and we don't want that. All right, so we're actually building some tables here. You can see we have integer and real and text for big text. We have everything that we are familiar with in other relational databases. So the schema is ready. Let's start saving data into it. OK, so we're going to have a function called saveAtmospheric_metrics. It's going to create a connection to the database and then begin a transaction. Remember, we said that we have to be transactional because either we save all the data set or nothing. We're going to create a prepared statement. This is Node native stuff, yeah? Prepared statement with the insert, and then statement run the SQL, and eventually commit or roll back if there's an issue. Okay, very standard stuff that you would expect from every relational database, all native to Node. So we're saving some data in the database. You can easily have viewers to the database. You can see it inside your VSC if you want. There's the plugins. You can do whatever you need there. Okay, and it's just saved. Good. Now let's fetch the data. So again, connecting to the database, creating a prepared statement. This time a join, just because I can do that. And fetching the data, you can see it in line 90 that I'm using statement.get. Statement.get returns the first record or undefined if there are no records. I can use statement.all to fetch all the records. And this is all native. Cool. So now I want to do something much more complicated. It's a late hour, so be with me here. I want to be able to run JavaScript code inside my SQL. So I'm creating a function called getAtmospheric_dynamic_average. I'm basically running a simple reducer that runs an average. Okay? I'm calling dbaggregate. This is available only from version 24. And it has 3 functions. It has the start, which is the start state. It has the step, which is the function that runs the reducer. And it has another function that once the step is done, the result is actually being calculated. Once I have that, I can run a JavaScript code, an SQL code that uses average.js. This is the function that we just named earlier. Inside our SQL, it's going to fetch the data, run these functions, and we're going to then running get or all, and map it to an object. I hope that's clear. Very powerful things that you can do in process. OK, so I kind of want to pause for a moment and go a bit deeper into something I mentioned earlier. Every Node developer knows the golden rule. Node.js is single-threaded, non-blocking, and asynchronous by design. That's how it handles all these calling to or fetching from files, accessing files, network, and so on and so on and so on. And these are, as you can see, promises. You are familiar with that. But here's the thing. Asynchronous is not the default or automatic. And it's not always the best tool to do the job. So I mentioned that earlier that the new Node SQLite API is synchronous, like better SQLite 3. And at first, this might sound strange. We're used to async, as I said. But if you think about it, SQLite runs in memory. You can run it in memory. And once it's in memory, it's CPU bound. It's not about accessing the disk or going to the network. And if that's the fact, then the fastest way to go is synchronous. And if it's that fast, it's not blocking anymore. The benchmarks that I have seen are showing that the synchronous method is 10x faster than asynchronous. And this is why Node team decided to build it as synchronous. And if you somehow have a long or like a long-running SQL or a big query, that can happen. We all had that in the past. No worries, because this feature, SQLite, is actually supporting out-of-the-box cross workers. Okay? Which means you can just create a worker or a thread, run that longer query somewhere else, not on the main thread, not blocking it, and then return the value. So what I like about this feature is not just the performance or the simplicity, it's the mindset. It's a small, reliable engine that does one thing and one thing well. There are no servers, no setup, no noise. Just data and structure and control, right where you want it. You can think about the usage here, right? You can use it in embedded solutions, in tests, in tooling, when you need to share state between threads, and so on and so on. That's a really nice solution for all these kind of problems that we're facing. And now, SQLite is baked into Node, and that's not just a good developer experience, that's powerful. I want to invite you to use it, okay? You actually still get the the experimental warning, but I'd like you to start using it. I talked with the team. They're very eager to hear about your comments and learn more, what you need more about this. And to conclude, I think we started with a vision, sending the code to another planet, collecting signals, chasing these signs of life. And to build that, we needed tools that are fast, reliable, and local. And now you've seen how Node SQLite fits right in. Sometimes the best tools are the ones that are just out of the box. Thank you very much.